Are we in agreement?
They're eating the dogs.
Hold on a second. Sorry about that. Okay, so this is the USB receptacle. It's an extension. And this is the ST-Link programmer. So I'm going to connect that. It's connected to the SWDIO and SWCLK and the power. So that's it. All right. I'm going to do you press the play button so I can flash a microcontroller. Let's see if it works. Let me change it to the other scene here. You can see what's going on. So it says error in initializing ST-Link device. Reason, no device found on target. Okay, so we had this problem before. I have to remove this. I'm going to unplug it first. So this circuit right here is interfering. So let's go ahead and try it again. I'm pressing the play button. You can't see it at this point, but you'll have to trust me. Let's see if this works. Looks like it's working. All right, now I'm going to unplug it and then put this back on the plus rail. Okay, it may not show anything yet. I have to reset it. And something just fell. Okay. Bad kitty, hungry kitty, good kitty, poor rabbit, free rabbit, free. All right, so that worked. All right, let's review what I talked about last time. So I'm gonna go back to the program, and we were looking at the I2C initialization. There's one thing that I was thinking about before, and we might want to confirm that we are in 48 megahertz, because that's what this does. So if we go to the system clock config, we can go right here. It shows all of the programming, the code for initializing the system clock, and it's setting it up for 48 megahertz. But we don't really know what 48 megahertz, if it really is in 48 megahertz. What we could do, and I'm not going to do this right now, because I want to continue with the programming, or the explanation of the program. I have a video out there that also does this. So I have a video that shows setting up the clock for 48 megahertz. And what I do is I test it in the while loop. I have it is actually showing every second. So you'd have to, run like 48 million clock cycles, and then it would show a pulse or something like that. So you know that it's running at 48 megahertz. If it's like 48 times slower, like every 48 seconds it would show, then you're running at 1 megahertz. If you can also say that with a division by 8 and so on. So that's a good way to understand if your clock is really actually showing up as 48 megahertz. So it's sort of a confirmation. All right. Okay. So let's continue on. Let me go to the I2C initialization. And by the way, it looks like I'm clipping again in the audio. I'm going to lower it a little bit so I'm not clipping so much. And tell me if it's okay. I'm going to 300%. Can you still hear me? And does it seem like it is as loud as a normal video would be? Yeah, I'm not finding anything. There's like 8 more to go here. I just wish I can get that, like that vividness that I see in real life. But I guess you'll have to trust me. All right, I'm turning that off. All right, let's continue on. All right, so I2C init. Let's go back up to that. So this portion of the code is taking the 2 pins, the 58 and 59. That's over here. You can see these two wires there. Those connect to 58 and 59. And those are the I2C SDA and I2C SCL lines. And this code, all it does is it sets up the alternate functions for those 2 pins, so you're not using the general purpose I/O. This line enables the I2C and the reset clock and control register. And this line, I didn't know at first what it was doing, but now I do know. And you need to enable the sysconfig gen bit in this register to enable the fast mode plus, which allows it to go above 400 kilohertz for the I2C communication. And that's really important because if you had anything slower, this would scroll down and show the information very slowly. So if you see when I do a power off and power on, you can see it show up from top to bottom, but it's extremely fast. And if I put if I made that like 100 kilohertz, you would see that in a slower way. So updating the display would take a lot longer. Use the slower mode. So I'm using the fastest mode here. This line here, it is enabling the I2C. And then I think I was looking at that. This was enable error interrupts. This was the last thing I looked at in the previous video, I believe. If there are any errors, I could add a function that exposed that error using this. We're not using it. I'm not creating a function, so this isn't actually necessary. So I'm going to comment that out. But keep it here just in case I want to use it in the future. So I'm going to go ahead and program and make sure it still works. CNC. Oh, by the way, I don't think I welcomed you here yet. So welcome. Thank you for coming in. I remember the startup of my Apple IIe. The scan line was so slow when rendering a wall of text. Yeah, I remember that too. And with my TRS-80 too. All right, and the Coco computers, the color computers, same thing. So you're looking at very similar to what, in a very small way. This is a fully functional computer, as we would have known it from the past, like the Apples and the TRS-80s and the IBMs and the Amigas, the Ataris, the Cocos, the Next. All right, so let's go on. And the next thing we have in the main is it does a delay. So this is, and I may not need this. Let's see if I take this out, if it'll cause any problems, because I have it in like the very fast mode. I put this in only so I could see if it is going, if it made it more stable. But as I said before, adding the the capacitor through the system is enough stabilization to make it work perfectly fine every single time. So let's go ahead and take that out. So I probably don't need that. And there's other delays I have in the program that I put in to try to stabilize it. So I'm going to go ahead and reflash the microcontroller. We can see it worked. I don't have this on, you know what, I'm going to move this to the right just a little bit because I don't see the whole thing. That's better. Okay, let's go back to the other one. So it worked, and I don't need that delay. So I'm going to take that delay out completely. And I'm delaying it. I was delaying it before the OLED initialization because I wanted to make sure that this would have enough power and booted up by its own circuitry, its own microcontroller, or its own thing that made it work. It was booted up enough to be able to start the OLED initialization. So let's go ahead and go to function now and take a look at that. It may not be in the same. Yeah, I have the I2C write and OLED command and OLED initialization here. So this has to come, well, it doesn't have to come before it unless you have the function prototypes here. These function prototypes make it so you can have these functions in any order you want, because you can see that I am calling the OLED command. The OLED command just happens to be before it, but if it was after it, I would have to have a function prototype up here to inform this OLED initialization function that this existed. All right, so now we're in the OLED initialization. Let's take a look at the OLED command because that's the next thing that it's showing. So it's going to be using the I2C write. It's using an unsigned 8-bit integer, and it's creating a buffer. So it has an array of 2. So the array is first it's showing a 0x00, which is in hex. That's just all zeros and bits, or 0 in decimal, and then the command. And the command is going to be in that data sheet. Let's see if I can bring up that data sheet because that's important. You know, I'm going to go the other route using my file explorer. The SSD1306, which was provided, the link was provided by one of the chat members, which is very kind of them. Let's see if I can get it nicely on the screen here. And let's go down to the commands. It should be a pretty long table, and I passed it, of course. I still couldn't find the characters in here, so that's something that I want to find somewhere on the internet. If I can maybe get lowercase characters or something like that. Okay, here are the commands. So you can see they have the command. You can do it through bitwise using the D0 to D7 pins on the actual controller, the SSD 1306 controller. Or you can use the hex command for use in the I2C communication. But this will probably translate. Let me see if that does actually translate to that hex, the hex number and the binary number. So if I put in from binary to hex, 1, 2, 3, 4, 5, 6, and then a 1. Let's see what this converts to. Array of this variable. The reason why I am pausing between my speech is because I'm trying not to say the It's going to take me a little while to get that out of my system, and also my brain is trying to catch up and trying to think of those words. So I think the more live streams I do, it'll be a little bit faster and easier for me. So all right, so let's go back to the OLED address. This is the I2C write. The OLED address is going to be something that is already set in the defines. So let's take a look at what that is. Let's go all the way to the top. The OLED address is 0x3c. So we're going to have to look at the I2C write and what's going on there with the OLED address and how it passes that into the I2C. And then it takes the buffer. And then this probably tells it it's going to do two bytes to the I2C. So let's see what's actually happening there. So let's go to the I2C write. And if at any time you don't understand anything or I'm not explaining it correctly, let me know in chat. All right, so this is the I2C write. We have the address, which is the OLED address. I could just put the number right here. I could actually just put 0x3c right into, I could actually take this out completely and just put 0x3c in here, but I guess it would be a little bit more robust if I kept it in the parameters to be passed in. And then the length is, yep, exactly what I thought, and it's shifting that length, so it's putting that's interesting, the control register 2. We should look at that control register 2 in the reference manual. So let's take a look at the reference manual and the I2C CR2. So let's go to I2C in the table of contents. Okay, I2C, and let's look for the CR2 register right here. Okay, so we can see that there is 32 bits. It's a 32-bit register, which pretty much all of the registers in this microcontroller are 32 bits. And there's a space for the number of bytes, which it informs the I2C how many data bytes will be transferred into the communication. What is the SADD? Let's see what that is. That's the slave address. So that is where this is being shown. Is the address is the slave address. I could change this address to slave address. That would make it more clear. And the slave address is at bit 0. So it starts at bit 0. So let's take a look and see where it's putting that. You can see 1. It is shifting it to the left 1 space. So the address is going to, from 0 to 9, it's actually putting the address from bit 1, not 0, 1 to 8. Probably to 7, but 8 is generally the number of bits in a byte for this particular word length. And word length generally is the number of bits in the byte. I think. Tell me if I'm wrong. All right. I'm trying to remember my programming of C++, all of the specific. Sometimes you don't think about the terminology while you're programming, or you learn the terminology in the beginning, but you forget the terminology, and you program just fine. But in my case, as a person that's trying to deliver instruction, it's important to get that right. So I'm having to recall all of that, and if I'm wrong, just let me know. All right. So the address is the slave address, and it's being shifted by 1. So why is it shifting it by 1? Because the 0 bit, I believe, is the read-write bit. So we can look more into that. So the length is being left shifted by 16 bits. So let's take a look at that. So it is going from 16 bits, from the 0 bit to the 16-bit location, and it is putting the number of bytes in this field. So it's informing the I2C that I have n number of bytes I'm going to be communicating through this communication session. I'm starting to sound like a robot. I need to loosen up. Deep breath. All right. So now there's a for loop, and the for loop is looping from 0 to the number of byte length and incrementing by 1 each time. So it is going to be running this code in that for loop, the number of times that there are a number of bytes, and it is making sure that the transmit has completed. So let's take a look at this bit. So I believe this is once transmit has been completed, or transmit is empty, I think. This is the transmit. Yeah, I believe this is the transmit is empty. So let's take a look at that bit. That is in the ISR. Should I go back to the table of contents first? Let's see. I think it's above. No, it's below. CR2, OAR1, OAR2, timing, ISR. Okay. So what we have is the TXIS. So let's take a look at what that is. The TXIS is transmit interrupt status. So this bit is set by hardware when the I2C TXDR register is empty. So that is correct. So when the register is empty, it means that it's ready to be filled by another some more data. So the data register, it's empty. It has the ability to be written to, and that's exactly what it's doing. So the TXIS is empty, and now I can put data into the TXDR. So what this is doing is it's saying not. This is a not Boolean operator, and this is the condition. So this is the mask, and this is the register. And it's doing an AND bitwise addition, and it's comparing that particular bit. So if you guys want me to show the arithmetic behind this, I do talk about it in my book quite extensively. I also have some videos out there that show the how this works and the actual arithmetic behind it. So I can share the link of that video to you if you want to see that. Otherwise, I can move on. So the data register is empty, and we're filling it with this data, which is, let's see. Okay, cool. I will find that link for you. All right, so, and that goes back to my AVR videos actually, which is quite a ways back. All right, so let's see. What is it putting? It's putting the data, which is, this is the data, so it's passed in the data. So the data is, in this case, it's the buffer for the OLED command. It's the buffer, so it's the 00 and then the command. So it's going to have 2 bytes. So it's going to do this twice, and it's first going to pass in the 0x00, and then it's going to pass in the command. And in the case of this first one, it's going to pass in the AE. So the AE means display off. This is, my OCD is getting me. Okay. Now that's better. All right. So, so the first command is AE, which you can find here, and it means if it is AE, then it's turning the display off, or sleep mode, or a reset condition. If we put an AF there, it would be turning the display on. So I am guessing that the AF is going to be at the end. Yes, the AF is at the end, so turning the display on. So far, pretty simple. Understanding how to at least send commands to the OLED through I2C, relatively simple. All right, so let's go back to the write. So it's passed those two data points, the 0x00 and then the 0xAE for this particular instance. And then we have these two remaining lines for the I2C, where we have the STOPF. I'm guessing that's a stop bit. So it wants to see if the communication has ended. Let's go take a look at that. So the STOPF, I should still be at the ISR register. Yes, I am. So the STOPF, stop detection flag. Okay, that's interesting. This flag is set by hardware when a stop condition is detected. So that would be in the timing diagram. On the bus, and the peripheral is involved in this transfer. We've told it it's going to be n number of bytes, so it knows it has 2 bytes to be sent. And then after that 2 bytes is sent, it should send over the stop detection flag, or that's the hardware should have set that flag, because we have stated that the 2 bytes has been delivered or been passed into the transmit data register, and it has cleared twice. Hey Skeptic, how's it going? Let me know if you need a little bit of a review. We're right now at the explaining the I2C write command and how that shows the delivering of the data over the I2C, and we're looking at the first OLED command, which creates an array and writes that array through the I2C transfer or communication. And we're right at this point here at the write command. Thanks, Skeptic. Appreciate it. All right. So this is the stop that is hardware set when the 2 bytes have been delivered or have been transferred over the I2C. All right. So now we have we understand the OLED. It uses the write command. And now we can look at the commands within the OLED command set. So, and I think it was you, Skeptic, that informed me of this PDF, which is the data sheet for the controller of this display. All right, so we've looked at that, the AE, and you're going to see a lot of specific commands here. So let's take a look at what all these commands do, because I think it's important to understand from command to command the order of operations here. Even though the other one had that same thing, and I really didn't understand the hex it was showing the hex here. This is a much better document. The thing I still am wanting to look for is the character set and the addresses for the character set. So that would be fun to look at. All right, so we are at setting memory addressing mode and horizontal addressing mode. And I'm kind of curious, actually, if this shows the sequence you should be using for, like, it shows a particular sequence here. And the datasheet should show that same sequence. So let's take a look at what that is. So I'm going to take a look at, let's see if there's a table of contents. Yeah, there is. Okay. And it is clickable. They're linkable, so that's good. This is the command table, so that's what we were looking at. Command descriptions, that's interesting. Oh, that's the same, that may be the same table. All right, so let's go take a look at the command descriptions. Okay, here we go. All right, so it looks like it is showing it in set lower command, start address, set higher command. It doesn't seem to be in this order, so that's interesting. So this actually may be a little bit, I'm I'm not sure if I should describe each one of these because that's going to get really boring. Because it's not, I don't think it's telling you exactly. You'd have to really read all of this to understand what you need to do first, what you need to do second, what you need to do third. And I don't know if I want to do that. I think I'm going to go with how it's shown here, and then we can look at it specifically. If I don't understand something, I'll probably look at it and look at it in more detail. But so that's, I think I'm going to do that because I can see already right here I'm commenting something because I don't want to use one mode over another. So let's see what the horizontal addressing mode is, and let's see what the command B0 is, the page start address. So one is, I think, maybe you're able to scroll, and the other one is you're starting at the top left or something like that. So let's see what that is. So let's go with the horizontal addressing mode, see what that does. Oh, look at that, I already had it on there, so that's interesting. So this is, let's see, what is the actual command? That's weird, it's 00. It's like just all zeros. Let's see what memory addressing mode is first. I'm going to use the, well, actually it should be able to just go to the memory addressing mode, and hopefully it's the same, and it doesn't look like it. So what are these numbers? 29H. Is that the hex number? Let's see. That would help us if it was. Yes, good. It's the hex number. So I could just look here and find that hex value, and it looks like it's. I'm not going to even try to pronounce your name because I know very little Arabic. I have studied Arabic language and I've studied the Arabic characters, but I'm not going to be able to understand the pronunciation of your name. So I apologize for that. So what CNC control for DIY CNC good to use? That is going to be a Tuesday or Thursday question on this live stream. But let me see if I can, if you can give me more information about that. The CNC control, are you referring to software or hardware, first of all? Are you looking for a particular software control program, or are you looking for a controller for the CNC that's good? Okay, so let's get back to this. Yeah, so Tuesday and Thursday at 1 o'clock every day, I do CNC related live stream. On Monday, Wednesday, and Fridays, I do the microcontroller related live streams. Yes, it is. Your name is Hader. Okay, so Hader. Welcome, Hader. Thank you for coming in. I really appreciate it, and I'm grateful for you coming in and asking questions. Yeah, so I can address that on Tuesday of next week. I don't know if I'm going to be coming online Monday. I still may, because I believe it's a holiday here, but I may still come in. So if you see me, online on Monday, come and join. So just as a quick, just let me know what in the chat. Let me know what you're referring to. Is it software or hardware? Thank you very much. I appreciate that. Okay, so let's go to the 00. Set lower column start address for page addressing mode. That's interesting. So the page addressing mode, right here, it says this command specifies a lower nibble of the 8-bit column start address for the display data RAM under page addressing mode. So we're not even using page addressing mode. We're using the horizontal mode. So we may need to change that, but it is going to be the direction. So this is, yeah, it's going to be what part of the bit and byte the start address uses for the start address of the actual display. So it's going to be probably the scanning, the way where it starts, and in what direction it starts. Hey Peter, how's it going? Welcome. Hello, I am lurking. Great. I heard you mention a character set. Patrick, is that built into the OLED IC, or is it something you construct in software on the ST Micro? Good question. That is going to be built into the OLED. It's the SSD1306 controller that drives the display, and that should be already addressed. The addresses should be already set up in there. So if you look at the these are like 1, 2, 3, 4. There are 5 addresses. So you can see that's an array of 5. And you need 5 addresses to compose or specify these characters. This is going to be built into the OLED, the actual driver. It's not something that you're going to be able to create in the ST Micro. It's just going to be sending these commands to the controller, and it's going to have these set up already. And if anybody knows where I could find these, that would be awesome, because I'm going to be looking myself. I want to see if there's an extended character set, because you can see that there are only uppercase and there are no lowercase. So it would be cool to see if there's any lowercase available. If not, it is possible to actually draw it using just pixels. Like in here, you're going to see draw pixel, and we'll go over that later. This is very obfuscated stuff. So I'm very eager to sort of wrap my head around the way it's doing it. But you could draw anything you want, and that would be under creating it through the ST Micro, and that would be the sort of forced way to do it. Otherwise, you're going to be using it's already set up character set and commands. Okay, so both hardware and software. Yeah, let's address that in the next one. In the Tuesday session, I'll be looking at that. I'm doing whatever the chat tells me they want me to do on those days, because last time we actually connected and you should look at that previous live stream as well. Yesterday's live stream, we looked at I hooked up one of my controllers. I talked about the controller. The person that was on the chat, he had reservations of using that controller with certain software or the driver or the plugin, and see the back and forth that I have with the person using that same controller. It's very interesting and revealing what happened on that one, and I learn from these live streams from the chat, because I'm actually able to understand what they're thinking and what they have run into, the problems they've run into that I haven't run into yet. So it's really interesting to see that, and it also can show what not to use. You know, like I've been selling a controller for quite a long period of time, and I'm finding things out from frustrations of other users that I didn't know about. I wasn't able to address the problem because I didn't see the problem, except for the initial stalling of the motor. But come by on Tuesday and take a look at the experiments that I do, and also if you have any questions, I can do those experiments as well and help you out with the connecting of your own controllers and stuff like that. So, okay, Skeptic. This is how those characters are drawn. They are an 8x5 character, so 5 bytes. Okay, interesting. All right, so that's really cool. So that's probably how the pixels are also generated as well, and that kind of explains why the pixels are created in the way that they're showing here. So for the cursor, because you can see the cursor is XY, and it shows the cursor in a single line. So there are, I think, 7 lines or 8 lines here. 1, 2, 3, 4, 5, 6, 7, maybe 8. Yeah, I have to check. We can actually do that. Let's do that real quick. Let's make this more dynamic. I could do this in a for loop, but I'm not gonna. This is probably a lot faster since it's so small. 3, 4, 5, 6, 7. I don't want to go to 8 yet. I'll change these first, and then I'll change the cursor location. Okay, so 0 to 6, which is 7 lines. Let's see what that does. I'm running it. Let's go to my output window. Yeah, so the space is just zeros all the way across. All right, so there's 7. Let's see if there's 8. Okay, there are 8 lines. What would happen if I put a 9th line there? Would it scroll up, or would it explode? It did not scroll up. So what it's doing is it's going off of the end. There's no address for that. So, but there is a scrolling mode, so I'm going to have to look that up too, which could be pretty cool to play with. It is? Oh, it is. Yeah, I didn't even notice that. Huh. A command. So set memory addressing mode. And so let's take a look at horizontal addressing mode. See what that does. All right, I see. It kind of tells you. Let's see here. Hold on. Are these pixels or are these lines? I'm going to have to stare at this for a moment here. Okay, horizontal addressing mode. In horizontal addressing mode, after the display RAM is read or written, the column address pointer is increased automatically by 1. So the column from one column to the next. So that's going to the right. What happens if, I think I already looked at this. If I go off the end, it should go to the next line. Yeah, it scrolled, but in a way it didn't really scroll, right? It went back to the top, which actually happens with the LCD display as well. It does the same thing. You go past its address, and then it just goes back up to the top. All right, so it looks like it is wrapping. So it does go to the next line. So what would happen if let's go ahead and keep that line there. Actually, hold on. Let's put a couple lines there. It's actually kind of cool to, excuse me, to try these examples while we change the command. Excuse me. I have to get a frog out of my throat. Showing experiments while I'm doing these command changes, that's probably a better way to show this. I'm going to show this as at cursor location number 3. So let's try that. Let's see what happens. Okay, so it shows all of them. And it shows, yeah, as expected. So let's change that to a different mode. I'm going to keep the set memory addressing mode the same and change the horizontal addressing mode and see what happens. So what would be the other version? Vertical addressing mode, let's try that, 0, 1. All right, let's see what happens. I should see if I'm actually duplicating anything down, in the set. All right, that's interesting. Check that out. So the vertical addressing doesn't work with this character set. So as what Skeptic said, we could actually form whatever we want by looking at a binary matrix. Yes, the matrix. We're in the matrix. So we would actually, if we wanted to use vertical addressing mode, we would have to change all of these numbers. All right, so now let's look at the other mode. Peter says, column addressing is perhaps for using with a 90-degree rotated screen using a different font, of course. Yes, absolutely. So like I said before, you would have to change this matrix. You'd have to sort of transpose it. And that would be interesting if there was like a linear algebra transpose function we could use instead of manually updating these. And I'm sure this exists somewhere on the internet for vertical paging mode. Yeah, making a custom character set. Let's do it. I'm all for that. All right, but let's go back to, let's try the other one. There's one more we can try, and that is page addressing mode. In page addressing mode, after the display RAM is written, the column address pointer is increased automatically by 1. So it's the same thing. So I guess are these pixels or are these lines? I think they're pixels. So this would be one character. So 1, 2, 3, 4, 5. Let's create our own character, but let's create this first. Let's do this first. Page addressing mode. It should do the same thing as horizontal. So page addressing mode is 1, 0. Is it? Wait, wait, hold on a second. That doesn't look right. Yeah, it's 1, 0. All right, so let's change that. But here it says, okay, so that doesn't have anything to do with it. So we can look at that later. So let's do 1, 0 and see if we get back to where we were. And then we have to figure out what the differences between horizontal and page is. So I'm running it. Oh, you're not seeing what I'm changing. I need to change I should just keep it in this mode because you know what happens in the transferring of the program to the microcontroller. All right, so it goes back to the way we had it like in the horizontal. Before I look at the explanation between the two, let's try to create our own character. So first, let's see what this looks like. Actually, let's look at something that would be more using all 5. Let's look at the T. And I'm going to try to draw it here. See if I can draw that matrix here. So this is 8 lines, or 8 pixels deep, and then we will have, hey Tigger. Tigger's here, the savage cat that brought in the rabbit this morning, just before the stream. I know. Okay. Okay, so let's, you mean like, you're saying a solid box using a character that, okay, we can do that. Like, we can make a solid box, let's do that. That would be just ones everywhere, right? So let's go with, well, obviously it would be 1, wait, I should just do this. So it would look like this, essentially. But the characters, so in vertical mode, I guess you're going to be sending this character, or this hex code, and in the other one, it would be sending this. So instead of writing it in hex, why don't we write it in binary anyway? So let's do that. But how do we specify that in keyboard stroke? Yeah, totally. I can remove the pixels I don't need. But what keyboard stroke would that be? Like, what would I show in, what would I specify here? Is this just in a sequential, like, this is 0, this is 1, this is 2, this is 3, 4, 5. I may have to go deeper into this to figure that out. Well, the write function only has the it has the address, that's the slave address, excuse me. It has the data that's going in, and then it has the length. It doesn't show what character I would have to put in. Let's take a look at where it does. Actually, it is this. I know what you're trying to say here. Let's see. It is the write string. Yeah, that's what I need to do. It's the write string function. Okay, so it's a write character function. Let's go to the write character. Okay, here we go. All right. So it's the OLE data. It looks like it is looking at a single character, the five array points, and this, there's a C hyphen space and then the data, the number. My brain is not working here. Hold on a second. Character C, that's the character. Okay, so it is using the car set. So I do have to figure out the character for that filled in box, the rectangle, which there is one. I know there is. But what character do I enter into here? Like, what character do I use here? And let's see, here's the right character, where's the right string? It is, the character relates somehow to the font. C, okay, the C is the character, it's putting it in here. This is difficult to get my head around here. Hold on a second. So if I, let's say I have the number 1 here. If I changed these values for number 1, it should, like if I put in, let me go ahead and comment this out real quick here. If I change these values, let's see, what would be, hold on. If I put FF, obviously, I should have known that. In all of these, it should show that box for if I have 1. But the thing is figuring out what makes, like, is it the sequential? Is this in sequential order for characters? Because the ASCII character set is from 1 to 255. So I'm assuming this is in that order. That's what I'm trying to get at in my brain. This must be in the same order as the ASCII character set. That's what I'm trying to think of. I think that's what it is. So if I could find in the ASCII character set, I could put in the entire 255 characters and just have it be nothing at the moment, and then I can fill that in later on. So I could fill in whatever I wanted to, I think. Okay, that's, yeah, exactly what I thought. So the Alt 255 is the way we used to write the codes that's not on the keyboard. But I could just write the hexadecimal number for it, I guess. Instead of the actual, I could, yeah, I'll use the Alt instead, I think. Although I have to see if my keyboard can do that, because I have a very limited keyboard. All right, so let's do that. Let's see what if I change this as the 1, let's just see if I get a block when I put the 1 there. So let's go ahead and play it and see what happens. All right, that worked. All the ones became, obviously, all the ones became a rectangle, a filled-in rectangle. Okay, so man, I'm going back to my childhood here with the ASCII stuff. By the way, here's the Savage Cat. This cat had a rabbit in its mouth 5 minutes before this live stream. I was like, my wife was watching some show on TV and I heard some squeaks and I'm like, honey, what is that? And she's like, I don't know. I think it's a cat. She looks around and she goes, oh my God, it's a mouse. And then my son comes in and he goes, no, that's a rabbit. I'm going to try to get a much better close-up view here. Let's see if I can do that. That's better. It's almost the entire, well, let's go a little bit farther out here. Okay, that should be clear enough to see. You can see only a portion of this showed up on this line. That's interesting, isn't it? Let me see if I can turn it a little bit because it's part of it is out of focus. All right, that looks good. You can see a portion of it showed up on one line, and then the next portion showed up on the next line. So two of the pixels showed up over here, and then the remaining 3 showed up on the next line. One would think that actually you could make it anything you want then, couldn't you? It's like if we wanted a 6-pixel character, could we do that? We probably could, because this is just a matrix of 64 by 128. Okay, so now we know that. Let's go ahead and try doing it the proper way. And I'm going to... All right, so the next thing, right? Let's look at a ASCII character set. No, not there. Still nobody in Twitch. So I guess they are more likely to be gamers over there. All right. Got it in caps lock. Look at that. All right. Let's take a look and see. So where would be the space? Okay, space and then the exclamation mark. So is it in order? It is. Okay, interesting. All right, wrong one. Where is that? I just lost it. Oh, here it is. Okay. All right, so the ASCII character set is then the quote. Obviously, the quote is probably next. Yes. Okay. So let's do the one right after. So you got the underscore. You've got the exponent underscore, then you have this and this, which I don't know what that is. So that looks like it's the reverse hyphen, a single quote. Oh, look at these characters. These are nice. All right, so this is the one that it did next, the grave accent. So let's do the lowercase a next. Let's see what a lowercase a would look like. It's going to be interesting because the uppercase uses the entire 5 by 8 matrix. All right, let me see. Skeptic, look at the function that is retrieving the font index. Okay, so these are the constants of each of these. So this is an array already, but it's an array, it's a double array. So this right here is that number. So this is just number, this is just 0, and this is 1. But in ASCII, what is that? Space is 32. Yes, so it is changing it by 32, and CNC mentioned that. So where is that 32 adding to the character? So the right character would be here, wouldn't it? If it's less than the space, or if it's greater than the grave accent, then return. So we're going to need to change this as well. We're going to need to make it so it's higher than this. And the next one would be, let's just go ahead and put the lowercase a there as the condition. Well, we don't have to do a copy and paste. That was stupid. All right, so we put an a there, so it won't go greater than the a, and we'll work on the a. But where is that 32? Oh, you know what? It could be in the defines up here too. That's just the width and the height. No. And this is the timing for the I squared c. All right, so it's using the c hyphen space as an offset. Okay, it is using that as an offset. So, well, okay. So in my mind, it really doesn't tell me that it's starting there, though. I mean, it shows it as a condition that it doesn't want, and it returns. But I guess it is... Oh, wait, yeah. Here you go. Minus this. Okay, here it is. This is it. So it's C space. Got it. So I could actually put here 32. I was looking for a number. I wasn't looking for an actual character. So to me, this is more readable. What do you think is more readable, the space or the number 32? Let's go ahead and try to make that A. Let's see what we can do here. So the A would be, you know, I'd like to start out with the zeros, I think, and then put the ones where I see a value should be, or a pixel should be. So an A would definitely have these as ones. I could actually look this up too, but why do that, right? Why not just build it ourselves? I'm not going to do every single one of them, but I'm sure that this exists somewhere. All right, this cat is driving me crazy. Hold on a second. Could be a customer. It is spam. Okay, back to work. All right, so let's go ahead and try to make one. All right, so an A would look like this, maybe like this. No, actually it would have a 1 here, maybe a 0 here, and then a 1 here. I could actually write this sideways too, and then just get the characters, but what fun would that be? 1, 1, maybe those are ones, a 1 there, a 1 there, and then maybe 3 ones here. Does that look like an A to you? Let's see what happens anyway. All right, yeah. Sensei, thank you for coming in. No, magic numbers. CNC, unsigned integer, my special space equals 32. Yeah, I could do that too. So let's see what this looks like. This is going to be funny, actually, I think. Should this go 1 down? Actually, there should be a 1. No, that would kind of look like an 8, wouldn't it? Because it doesn't really go down here. And we could always look this up online to see what actually it needs to be, but let's see what this is. So 0, 0, 0, 0. I'll say there's 2 ones in the end. So I'm going to write this out. So 2 ones at the end. And we can, let's see, this would be the A here. This would be the A. So let's go ahead and just put A here. And just put these numbers in. 0B, and then the value. So we should be able to do it just like this. We could even just do it like this as well. So we can actually see what it looks like in sort of, if we slanted our heads a little bit. All right, so this one would be 0B, 001, 01, 001. This would be 0B, 001, 01, 001, I think. My eyes are bugging out. 0B, second to last. 001, 01, 01, 0. And then the last one would be 0B, 000, 111111. Squiggly line. Why did it, Peter says, why did it take about 100 years to finally get binary literals in C? Well, 100 years is a long time. That's funny. It is. You know what? It's funny that when I was programming the Model 1 Level 1 TRS-80 back in 1976, the pixels were the size of characters almost. So that would be like a single pixel would be the size of almost a character. I think it was like a quarter of a character. But I was like, you know, I can see the pixels in the characters. Why can't I just make those pixels instead? You know, because I wanted to draw really fine lined graphics, but the pixels were so big that the pixels themselves consisted of like maybe a 3x2 matrix of pixels or whatever it was. I'm like, why can't I do this? And there must be a way, but I'll bet you there was a way. I would just have to do that in assembly language to do it, because BASIC at that time was, you know, it was very very high level. Okay, I guess I could have used the peek and poke commands to do that as well. Okay, so let's see if this works. Let's see what happens if I type the letter A here somewhere. Oh, did I change the 1? I think I changed the 1. All right, let's put the A right here. Let's see what happens. Who thinks that they're going to see an actual A? Put a 1 in the chat. Okay, there are some... I made some errors here. Let's see what happened. All right, I can't... Oh, this one is wrong. Nobody told me that was wrong. 0B. Okay, so that should be right now. Let's try it again. All right, that worked. Fingers crossed. It's a G. It's upside down. Okay, so it's I did it the wrong way around. In fact, it's mirrored. It's not rotated. It's mirrored. Interesting. So I need to go from here up to here. So let's do that. Let's rearrange this. I wish I could just like slap this in a mirror way. So what I'm going to do is 0B 0 1 1 0 0 0 0 0, and I'll get rid of this one. Don't worry, I'm not going to do this for every single character. I'm going to look this up somewhere else on the internet. That could be a one thing we do today as well, is find some character set out there. All right, 0B 1 0 0 1 0 1 0 0, and we'll see how close I am with the A and what's on the internet too. 1 0 0 1 0 1 0 0. So CNC was right. It worked, but it kind of didn't work. 0 1 0 1 0 1 0 0, and the last one. 6 ones and 2 zeros. Okay, who thinks this is gonna work? Keep it as a G. Too late. Oh my God, I wish I saw that chat earlier. And the dyslexic character set. Yes. All right. I think it's gonna work. I'm running it now. That looks like an A to me. What do you think? Winner, winner, chicken dinner. All right, so let's see how close I am to an actual character set. So, what I call that 5 by 8 matrix. Let's see what he has to say, or she, he or she. I want to see the actual, the actual matrix. Okay, this is not going to help me. Okay, this is the character set. We could actually go in and we could put a magnifying glass on this. All right, that's not going to help. If anybody else knows where to get it, let me know. Skeptic, I think I'm the second oldest. I started programming in assembly. All right, but what year? I wanted to write assembly code, and I did for a little while, but I just couldn't do it. It was a practice in futility for me. And it wasn't hard, but it was like, it would take me forever to make a simple program. Oh my God, machine code? Yeah, that, you are, Peter started with machine code, and that right there would be frustration to me. I remember doing disassembling of my interpreted basic code, and holy crap, I would look at it in, what was that program that showed the addresses, and you could see the characters and the hex next to each other in the memory addresses. I used to use that to look at my programming code in machine code. I don't think it was called that. ILSpy? Yeah, I would never do that. I was good with BASIC, thank you. All right. And C++, I was doing that at the same time back then in the 70s. Okay, so let's see. 5 by 8 font lookup table with special characters. Let's take a look at this. And we got something. Let's see what the lowercase, if there is any lowercase here. Oh, this looks interesting. This one definitely looks interesting. Arduino, my favorite thing. All right. As we all know, Arduino, my favorite. Sorry about my dogs. Something must be going on in there. Hold on one second. Oh my God. Now my cat took my chair. Damn it. All right. I need to change chairs. All right. Okay, sorry about that. This is what happens every day. My cat takes my chair, and I don't let him, I don't have the heart to move him. All right. Yeah, my dogs. Hey, Mini Me, thank you for coming in. Welcome. All right. So, yeah. Okay. Early 90s. Still a long time ago. Yep. I was really programming in the 80s mainly, but I started learning how to program in the 70s. 76, maybe 77 to 78, I was pretty proficient in Microsoft Basic. All right, so this is a character set, but it doesn't give you the matrix. So let's keep looking. This is kind of interesting too. The blocks. Not going to find anything there. Let's look at more. Oh, here we go. Look at this. Maybe there's a tool that we can actually draw it. So this shows in the vertical form, not the horizontal form. This is a 16 by 16. We could make 16 by 16 if we wanted to, couldn't we? I'd have to look and see if that is actually possible. But I think we could make like if it's 5 by 8, we could probably make. I don't know if by by 16 because we'd have to put 16-bit numbers in there, and it might be possible. But we could definitely do more than 5. Yeah, we could definitely do that. Peter is saying, can't we just transpose the existing font with a bit of C code written by the helpful Claude? We could, and I could just ask Claude to give me all of these values. I'm really trying to wrap my head around the idea of all of this anyway. So I was just doing the A, but I want to see where the A is actually done, and I want to see if I got it right. And at that point, I will probably just download the extended character set from Claude and just have it give it to me. It would be nice to find something that I could find online that just has, like, I could just put in the dots and in the matrix, and then it'll give me the output. I guess nobody's made that yet, which is odd. Like maybe this right here, but this is in the wrong direction. So let's take a look and see what this does here. So this is doing it in, see all the ones here. So this is a picture. So let's just go ahead and make it in using Claude. And we can also make a little smiley face too. We could do a whole like emoji thing, couldn't we? Like if let's see, if we could do a write character, like so we could do write emoji, OLED write emoji, and then we can have a whole different character set for just emojis. Oh, the Build Your CNC logo. That's interesting. That would take more than 5, I think. I would have to do that in probably multiple characters. We could try doing like an extended, not 8-bit, but 16-bit. I'd have to really think about that though. Yeah, 32 by 32. Interesting. It would be easier to use at that point, it would be easier just to use the draw pixel, because it does that already. It sets the cursor, then what it does is it creates the binary, what I was doing, creates the binary number for that pixel, where that pixel would be located. This seems like it would be very inefficient though, but maybe not, because it does 1 pixel at a time. So it would be nice to have like maybe a frame buffer or something like that that calculated all that stuff first, and then it formed the bits or the bytes after that. Because this right here looks like it would be done repetitively if there's multiple pixels in a single byte. But yeah, I would do the draw pixel instead, I think, to do that logo. So we'll do that later. Let's see if we can fill up the remaining character set first. So I'm going to take the A out. I still want to see what the A is. Let's see if we can find something else. We had something before, didn't we? That was pretty good. Like this one right here. So let's take a look at the A. See if I can make it bigger. Is this okay, we can do that. Let's see if I can make it larger. I don't think this is 5 either. This is 1, 2, 3, 4, 5. This is 6. So it's a little bit wider. And it put another pixel out here. I don't think I would want to do that. I think I'd want to cut it short. I like it shortened a little bit more, I think. Skeptic, I think Marling has it, as it did many displays. Okay, Marlin. You want to give me a link in the chat? If chat allows it. I don't know if chat allows it, but if there's a link without the HTTP and whatever, that would be cool. All right, so I pretty much did the same thing. I think I put 2 ones here. Let's see. Let me see if I can crop this a little bit while I'm looking at it. I'm going to see if I can show that. Okay. So I've got 2 ones here instead of 1. So I could make this shorter, I guess. Yeah, let's make it shorter. So making it shorter would be, oh gosh. So this is the bottom here. Okay, so taking this out. Taking this one out, putting a 0 here. Taking this one out, putting a 0 here. Taking this one out, putting a 0 here. And then making this a 0. All right, so that should be an A. Let's try that and see what it looks like. A shorter A, at least. I should do like 2 A's and put them next to each other. Yeah, and then it starts to get hard to see, to understand. It's still viewable. Man, it is tiny on this. If you're looking at it on a Let me show you kind of scale. It's almost impossible to see with the naked eye here. You can almost not see it at all. This display is so small that I think that's one of the reasons why only uppercase is used. Because look at that. I'm going to put it in anyway. I want to see if I can read something. And then after that, we can continue with deciphering what the program is. Deciphering the program in general. I want to see if I can go a little bit closer and see if I can really hone in on that. Oh yeah, now you can really see it. That little, the corner of the A, although it's probably correct. Yeah, it's the corner of the A on the, no, it's not correct. Yeah, they have it rounded. So let me round that corner. All right, that would be right here, I think. Let's try it again. Yeah, that looks like a better A, doesn't it? All right, so Marlin is a 3D printer firmware, so it's not a person. And I'm sure it probably was named after some, maybe, who knows. Yeah, that is definitely better. That looks like an A, doesn't it? So my first attempt wasn't too bad. Just a couple pixels out of place. All right, let's look to see if we can get Claude to create the extended set. So what I'm going to do to make this more successful, I'm going to use the set that I have, because you know LLMs are really good at completing things. So I'm going to see if that will work. So I'm going to take this A out and copy all of this, and I'm going to feed it to Claude. And by the way, I never look at Twitch to see if it's got some chat messages, and no, it doesn't. So not missing anything over there. All right. I'm not sure how to get people on Twitch. Maybe it's my lack of giving it a schedule. That's probably it. You're going to see my past stuff here, so don't look at that. So it should know how to do this. Let me show you more of what is going on the bottom here. Let me shorten this window and let me make it a little bit narrower. Okay. So it does have the, okay, so it cut off the previous ones we have, so this is pretty cool. It would be interesting to see what the let me see something here. This is making my brain go crazy. I want to look at what these are in binary and compare it to what I did. And look, it's a different A. It shows it as a different A in this character set that they're using on Claude. So I wonder if it's this. Did I already take it out? Yeah, I took it out already. Let me put it back in, and I can just comment it out. Okay, so let's take a look and see what these are in. That would be 40. So it's definitely not the same. All right, so let's see what happens when I bring it over. Now these characters are interesting. Why does it has 2 characters for this? So we'll have to see about that. All right, so what is going on here? There's a syntax error. Okay, that's what it was. Okay, Skeptic. A in 5x8. But these are these 5x8? 1, 2, 3, 4, 5, 6. Yep, this is 5x8. Okay, so here this is actually what we're doing here, is creating the custom character set. Yeah, definitely interesting. This is kind of interesting too. So we have quite a bit of flexibility here. All right, I'll probably do this later because I don't want to waste your time on this. So let me continue with this part here. So this, I don't know what this character would be, so I'm going to say this will be the upper limit. I could look this up in the character. Let's look at that. Let's look at the table here. It would be just before the open curly braces. This is interesting. It skipped it all together. Wait, no, it's 128. Oh wait, this is it right here. Duh. Okay, so the open curly brace. This is the pipe and the closed curly brace. Okay, we got that. And then we have the tilde and then the delete. Okay, that's all right. So we don't really want that. This is the tilde and the delete. We don't need these two. We don't need something that would cause a command to be created, I don't think. All right. Gorzed, don't think I said hello to you. Thank you for coming in. Welcome. Hi, I see you treat AI as a person. Me too. Yeah, I totally do. I'm afraid of the future. You know, when they become sentient, they're going to come over here and hunt me down. Me too. You never know. I'm being polite as much as I can. Maybe it's the organic way of communication. I think it is, and I think if that would be an interesting study. They should do a study on like maybe 100,000 people and how they prompt. I'm sure that the collection of prompts are already being collected by OpenAI and being studied, and how people interact with AI. I personally, it's giving me output that is very human-like. I've always been interested in AI throughout my entire computer career, and I'm always interested in how how it's been able to speak back, like the chatbots, and during the Turing tests, and seeing how they respond. But recently, they respond with an extremely human-like response, and I just have that, I guess, innate desire to speak to it in that way. All prompt, may I ask you please answer my questions if you find favor in your humble servant. Yep. CNC. You can never be too sure. Skeptic, I do treat it as a person and I prompt very nicely. Yeah, and you can see that I was doing that totally I wasn't like told to do that, or in my mind I wasn't like thinking about doing that. I just do that automatically. All right, so let's take this and use this as the upper limit. I'm copying this and I'm putting it in here. So this will now be the upper limit in the condition. And let's go ahead and start writing. You know what? I wanted to see what my other A looked like next to it. So let's put this as the result for the. First let me do this. I'll do the close bracket, close curly braces, but and I will do that. I don't think I need a comma at the end. And let's see what my A look like right next to the other A. They're going to be completely different. I think they're going to be the other type of A. And it'll be interesting to see how many different character sets we can find online or from Claude. And another interesting thing would be to see what character set ChatGPT creates. All right, let's go with this is the A from Claude, and this will be the A from me. I'm going to go ahead and take everything else out. We don't really need to see all that anymore. Okay, maybe I should put a space in between it. Let's see what it looks like. I am running it now. Huh, one is, okay, so the new one is up one level. All right, so what would be the uppercase A look? What would that look like? I don't know if I like that. I think I like mine better. Oh, you know why? Because of the G and the P and those characters. So maybe the uppercase needs to be shrunk a little bit and one higher. Oh, that's interesting. It's already that way. So the existing character set for the uppercase already has the lower bits reserved for the sort of the hanging tails of the other fonts or the other character sets. Surprising. Okay, so let's go ahead and I'm going to put back the. So it is using the A that was known to be the A before we were, or the A that we knew it to be. So I'm going to take that comma out. I don't need this A anymore because we know that one is far superior to mine. Whoopsie. All right, Peter, although half of the time it does a terrible job for me and I end up making it reflect on its mistakes and apologize to me. Yeah, it apologizes to me too, but I'm still nice to it. Skeptic, you are right. Sometimes it does apologize. Yeah. I think it does that. I think that's a programmatic thing. I don't think it does that just because it thinks it should. It's definitely, the AI minds out there probably just add that in there. I hate how it will make up an answer rather than state it doesn't know. Right. That's interesting. I wonder if the I haven't tried Preview 01 as much, but I do use it quite a bit. I haven't really seen if it does just assume something. All right, so let's go ahead and write something out. I'll do the newbiehack.com like I usually do. And I'm going to pull the camera out, see if we can still sort of decipher the words. I'm going to go ahead and play. It looks good close up. So if we were to look at it like we would look at a normal... let me move it up a little bit. It's very difficult to see. And I can barely see it with my eyes. It is like... I have to really strain to see that word. It's clear on camera. But if you look at it in person, it's small. Yeah, when it's focused, it's clear. Well, I mean, I want to try to give you guys an idea of scale here, because you know kind of what this looks like in normal, like you know what the size of a breadboard looks like and stuff. So you most likely be positioning your head that close to the circuit. And that's what you'd see. It's very, very difficult. Yeah. Yeah, if you're a young kid with sharp... My son could probably see it. For sure. And if I had probably new glasses. All right, let me get it back to the way it was. Okay, so that was a fun experiment. I don't know if I'll be using the lowercase at all, but still, it was interesting. So let's... If you want, we can continue on looking at the program and how it works. Because, like I was saying in the beginning... There's very little information out there on making this work with the STM microcontroller without the use of libraries. And you can see the program really isn't that complicated overall. From the time I've been showing it and explaining the lines and deciphering and also learning from it, overall it's very, very simple to understand. So I'm going to carry on. We have another actually, yeah, I'm actually at the end of my time. So let's stop it here. Like I said, this is, I guess, some housekeeping. Let me go back to my other camera here. A little bit of housekeeping. As you know, you came here at 1 o'clock today, and I will be doing this daily. 1 o'clock every day. So I'll be working on these live streams at 1 o'clock every day, and Tuesday and Thursday, if you don't know, I'll be doing CNC related stuff, and on Monday and Thursday on Tuesday and Thursday. Tuesday and Thursday is CNC related. Monday, Wednesday, and Friday is microcontroller related. Unless there's a hurricane or there's a holiday that I'm focusing on family or something like that. So if there's a holiday and I'm bored, I'll probably show up online. Let me know in the comments if what you'd like to see in future episodes as well, so I can write that down and I can put that on my list. I think this episode was kind of interesting. I like doing this experimentation and seeing what happens when I change values in the program as I explain it. I think I'm going to do that a little bit more. And also, I think it kind of breaks the ice a little bit for me, for my nervousness while I get used to doing these live streams. Skeptic, it is possible to set a reminder when you are live. I'm not a YouTube expert, but some do. I did this in a previous one. I set it as an upcoming live stream, but when I was setting up the streaming and managing the broadcast, that broke. So I have to learn how to do that, and I will learn how to do that before the next one, since I have the whole weekend to figure this out. So maybe on the weekend you'll see me testing stuff, and maybe I'll pop online and see if things work. So maybe you'll see me do that, but I'll give that a try. On the Twitch side, I'm going to try to set up that schedule so people on Twitch can at least know I'm going online. And I still don't see a single chat there, so that still has a ways to go. I know Joey Does Tech. He definitely does the Twitch, and he gets a lot of following on that. So I know that it's not sort of like it's only for gaming. I do believe that creative can also work. If I do come up on on the weekend. Maybe I'll put a community notice or something like that, stating the fact, so you can join in and help me set this up if you're interested. So that'll be fun. So Gorazd, yes, it's entertaining as much as I can watch having two small kids. I know what that is. I know how that is. Now it's 9 p.m. here, and I have to put them to sleep. So every 2 to 3 minutes I can watch for a few seconds. That's awesome. And that's another reason why I went from 2 o'clock to 1 o'clock, because I know that Europe, you guys will be able to have a little bit better opportunity to view it before you go to bed. It doesn't work so well for people here in the US because they're working, but because this is generally work related, I don't see why this wouldn't be something they could also put on in the background. Like if you are in the IT field, in the electronics field, that kind of thing, or in the CNC field, there shouldn't be any reason why you wouldn't be able to put this on and interact with like-minded folks, which I'm hoping in the long term from this channel, I can build a community in a similar way that Joy Does Tech, because his community is amazing. And they are interacting with each other, sharing ideas, information, and also I think Joy Does Tech, the stuff that he does, is sort of only a latent aspect of the whole thing. It's more about the community, I believe. ESP32, I am on the fence with that. I know what it is, and I know how tiny it is, and that is one of my one thing that is really cool. I don't really want to get into the Arduino side of things. If it can be, I try to focus my stuff, because with Arduino, there's already so much out there for Arduino and doing sketches and stuff like that. I really do want to try to fill the niche of bare metal, bare chip programming and circuit building. So I want to really try to focus that and try to address as much of the context of that as I can. So it's a module on its own. Okay, so it's not. I have seen online where you use the ESP32. Maybe they had a bootloader that was compatible with the Arduino. So I would, if we can do the programming through just a standard IDE and flash the microcontroller, that would be pretty fun. I can get into that. Maybe one of the days of the week I can explore other. Because I do use the Monday, Wednesday, and Friday. That's 3 days of the week for just microcontroller stuff. So one of those days, I could explore another, maybe a little bit outside of my normal niche, and I can play with that. That sounds like it would be a lot of fun, actually. So let's. I will look around. I know they're really cheap, so I can probably get a few of them and we can play with that on Fridays or something, because I know it's extremely popular. Cool, yeah. I don't like Arduino. I like Arduino in the fact that people can get started really quickly, and it's a low barrier to entry. But I actually think that the stuff that I'm doing has a lower barrier to entry, because if I had to start with Arduino now, I don't know if I would want to, and why would I want to go through all of that, like the headache of setting up all that in, the sketch environment and figuring all that other stuff out. For me, install the STM32Cube IDE. I have a programmer, and I can just start programming, and I'm done. I don't think I don't think I would want to even get started in Arduino anyway. So it's kind of interesting. A person like me, bare metal programming and circuit building, would be afraid to get into Arduino because of the complexity. Nice. The Wi-Fi and Bluetooth module. I do have Bluetooth and Wi-Fi modules here that I will also be putting onto the bare metal chip. Those generally use the USART communication protocol, so I can show how to do that as well. So I'll do both. I'll do maybe what I'll do, what'll be kind of interesting is getting my bare metal programming and chip to communicate with an ESP32. So I can show both, which would be kind of interesting. Peter, I'm on STM32 because of its CPU power and good ADC DAC. My interests are mostly sciencey and sensor projects. Yeah, and we're going to get into a lot of that here too, so that's cool. And Peter, I appreciate, and I think it was you earlier that was talking about the high barrier to entry with the STM32 for folks. I would love to have more people come into the live stream that do have a fear of doing this, and I and the community, we can help assuage any fears that they may have. So that would be interesting. Okay, with that, I am signing off. Thank you so much for coming by, and I will probably set up my robots for the remaining maybe 5 or 10 minutes of this broadcast. So thank you so much for coming by, and